Ramanujan for G is now available on the Google Play Store. Try it out for free.
Yeah, so good morning, class. In the previous lecture, we have started the maxima and minima, which is the part of AOD. Okay, it's applications of derivative. So now, today we will start with the algorithm for determining extreme values of a function by using first derivative. So we will start with for algorithm for determining extreme values of a function, by using first derivative test. Okay, so test first step one, put y is equals to fx. Then in step second, find dy by dx. Okay, step three, so put dy by dx is equals to 0 and solve the equation for the x. Means let c1, c2, c3 up to cn be the roots of equation, and c1, c2, c3, cn up to cn are stationary values of x, and these are possible points where the function can attain local maximum and the local minimum. So we test the function at each one of these points. Okay, after that, step 4, consider x is equals to c1 if dy by dx changes its sign from positive to negative as x increases through c1, then the function attains a local maximum at x equals to c1. Okay, local maximum at x is equals to c1, and if dy by dx changes from negative to positive, then local minimum at x is equals to c1. Okay, and if dy by okay, if dy by dx does not change its sign, x increases through c1, then x is equals to c1 is neither a point of local maximum nor the point of local minimum. So in this case, x is equals to c1 is the point of inflection. Similarly, we may deal with the other values of x. Okay, so let's look at some problem. So we will take one question based on this. So we have to find local maxima or local minima of the function fx is equals to sine 4x plus cos 4x. So x is in the range x less than, which is in the range from 0 to pi by 2, using first derivative test. Using first derivative test. Okay. So here in this case, first we have like function y is equals to fx, which is sine 4x plus cos 4x, right? So dy by dx will become 4 sine cube x cos x minus 4 cos cube x sin x, right? So it will be minus 4 cos x sin x and here it's cos square x minus sin square x, right? So it will become minus 2 sin x minus 2 sin 2x cos 2x. So it will be minus of sin 4x. Okay, so this for a local maximum or local minimum. For a local maximum or for a local minimum, we have dy by dx is equals to 0. So it means minus of sine 4x is equals to 0. So it will be minus sine 4x is equals to 0. So sine 4x is equals to 0. So we can say 4x is equals to pi, right? So x is equals to pi by 4. So if we talk about this for the left embedding of x is equals to 4, left x is equals to pi by 4. It means x is less than pi by 4. So 4x, so 4x is less than pi. So it means sine 4x is greater than 0. So minus of sine 4x is less than 0. So dy by dx is less than 0. Right? Similarly, if we talk about right of this x is equals to pi by 4. So in that case, x is greater than pi by 4. So it will be 4x is greater than pi. So sine 4x is less than 0. So which means minus 4 sine 4x is also greater than 0, means dy by dx is greater than 0. So thus dy by dx changes its sign from negative to positive as x increases to pi by 4. So x is equals to pi by 4 is a point of local minimum. Okay, means x equals to pi by 4 is a point of local minimum. Now for local maximum f pi by 4 is equals to sine pi by 4 to the power 4 plus cos pi by 4 to the power 4, which is half, right? Which becomes half. Next thing is if f dash x is equals to x minus a power 2n x minus b power is 2m plus 1. Okay, so where m and n belongs to natural number, then so basically we have to find the relation of x. Okay, so like it's a minimum, maximum or inflection. Okay, so let's solve this. So we have our function f dash x is equals to x minus a power 2n x minus b power 2m plus 1. So it means f dash x is equals to 0. So for x is equals to a to b. So for now x is equals to p minus of h. So it means f dash x is equals to b minus h minus a to the power 2n and minus h, which is 2m plus 1, which is less than 0. So for x is will become x plus h and f dash x is equals to b plus h minus e to the power 2n and h is 2m plus 1 is greater than 0. So here it means x passes through the point P. So f dash x, f dash x changes its sign from negative, right? So hence x is equals to b is local minimum point. Okay, so we can copy this problem. Now we will see higher order derivative test. Higher order derivative test. So here, like the value of function fx is at x equals to a is maximum. Okay, like the value of function fx at x is equals to a is maximum if f dash a is equals to 0 and f dash a f double dash a is less than 0. Similarly, the value of function fx at x is equals to a is not an extreme point for function, not an extreme point for function fx, right? So it means f dash a is equals to 0 and f double dash a is greater than 0, right? Next point, like if f dash a is equals to 0 f double dash a is also equals to 0, and f triple dash a is also equals to 0, then the sign of, let me write down then the sign of f to the power fourth a, the fourth derivative test will determine the maximum, will determine the maximum and minimum minimum value of function. Okay, means like fx is maximum, then if function for derivative a is less than 0, and if it's minimum, then f for function fourth derivative a is greater than 0. Okay, similarly, like f dash c is equals to f double dash c is equals to f triple dash c triple derivative. So which is also equals to, goes up to is equals to f and minus 1c equals to 0. And the last, like f and c exist and is like non-zero, is like non-zero. So if n is even and function fn c is less than 0, then x equals to c is local maximum. And if n is even again and f and c is greater than 0, then x equals to c is local minima. And if n is odd, then x equals to c is neither a point of, means neither maxima nor minima. Okay, so these are some things we need to remember. Now, like question is given, find the points of local maxima and minima of the function f x is equals to x cube minus 9x square plus 15x minus 11. So let fx is equals to x cube minus 9x square plus 15x minus 11. So f test x will be 3x square minus 18x plus 15. So 3 we can take common, 3x we can take common, so it will be x square minus 6x plus 5. Only 3 we have, only 3 take. Okay, so for minima and maxima, like f dash x is equals to 0. So x square minus 6x plus 15 is equals to 0. So it means x minus 1, x minus 5 is equals to 0. So which will become x at 0.1 and 5. So again differentiating f double dash 1, which is minus 1 less than 12, which is less than 0. So means x is, x at 1 is point of maxima. And if f double dash 5 is equals to 12, which is greater than 0, so x equals to 5 is point of minima. Okay, so like this, we have to solve problems. Okay, so you can copy this. We'll take more problems on this. Okay, so one more question. Like for the curve y is equals to x to the power ex, the point, like the point is a minimum point of minimum or maximum we have to find. So let's solve. So y is equals to x e to the power ex. So it means dy by dx will become e to the power x plus x e to the power x. So for maximum or minimum, dy by dx is equals to 0. So it means e to the power x 1 plus x is equals to 0, which is x is equals to minus 1. Similarly, d square y upon dx square, which is 2 e to the power x plus x e to the power x. So here in this case, d square y by dx square, x is equals to minus 1 will become e to the power minus 1 to minus 1 is greater than 0, right? So we can say x is equals to minus 1 is point of local minimum, point of local minimum, right? One more question is like the function fx is equals to this 2x cube minus 9ax square plus 12a square x plus 1 attains its maximum and minimum at p and q respectively, then p square is equals to q, then a equals, okay, so fx is equals to 2x cube minus 9ax square plus 12a square x plus 1. So f dash p is equals to 0 and f dash q is also equals to 0. It means f double dash p is less than 0 and f double dash q is greater than 0. So now we can say 6p square minus 18ap plus 12a plus 12a square is equals to 0. Similarly, 6q square minus 18aq plus 12a square is equals to 0, right? So here p is equals to a 2a. Similarly, q is equals to a and 2a. This is our equation 1. Next, we can do like f double dash p is less than 0. So it means 12p minus 18a is also less than 0. So p is less than 3 by 2 into a. So this is equation 2. Similarly, f double dash q is greater than 0 means 12p minus 18a is greater than 0. So q is greater than 3 by 2 into a. This is equation 3. So from 1, 2 and 3, p is equals to a, q is equals to 2a. So p square is equals to q. We can say a square is equals to 2a. So it means a is equals to 0 and 2, right? So but for a equals to 0, fx 2x cube plus 1 doesn't attain maximum or minimum. So for any value of x, so a we have to reject. 2A to select. So A is equals to 2 is our final answer or required answer. Okay, so last question for today's lecture. So A is greater than 0, B is greater than 0, and A plus B is pi by 3. So then maximum value of 10A, 10B is, okay. So that's all. So A plus B is equals to pi by 3. So it means B is equals to pi by 3 minus A. So which means 10B is equals to root 3 minus 10A divided by 1 plus root 3 10A. Okay, actually this is for the advanced question, like advanced problem. So next, like letter J will become Z letter, it will be 10A plus 10B, right? So Z is equals to 10A plus under root 3 minus 10A and divided by 1 plus root 3 of 10A. So which will be under root 3 10A minus 10 square A and divided by 1 plus root 3 10A, right? So here Z is equals to root 3x minus x square divided by 1 plus root 3x. So here x is equals to 10A. Okay. So we can write d z by dx is equals to x plus root 3 and root 3x minus 1 divided by 1 plus root 3x. So for maximum z, dz by dx is equals to 0. So it means x is equals to 1 by root 3 and minus root 3. So x is equals to minus root 3. We will not going to take because a plus b is equals to pi by 3. So which implies like x is equals to 10 is greater than 0. That can be easily checked like d squared z by dx square is greater than is less than 0. So for x is equals to 1 by 3, 1 by root 3, which is right, which is the z is maximum value, right? So 10 is 10a is equals to 1 by root 3 or a is equals to pi by 6. So value of x and z is equals to 1 by 3. Okay, so we are going to wind up this lecture. Okay, we will start the test and least values of function in a given interval in the next class. Okay, so thank you guys.